Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. I have started aldehyde, ketone and carboxylic acids. That is a new chapter, and in that I have discussed general things, means introduction I have given, and also I have discussed IUPAC name of aldehyde and ketone. Also I discussed carboxylic acid. Now I will continue IUPAC name, means nomenclature. I will continue with further examples. Then first actually I will discuss common name also and IUPAC name also for some common compounds or some common organic compounds. First I will discuss aldehyde. Already I have discussed, now it is just for practice. Then HCHO, first compound HCHO. Then now CHO, you know, it is the aldehyde group and only H is there. Only one carbon is there, CHO group, and H is attached. Then it is called, common name is formaldehyde. And IUPAC name methanol, because only one carbon is there, methanol. In the end, Al will be there. Al means aldehyde, methanol. From the methane, E letter removed and Al attached. Second is CH3CHO. Then now total 2 carbon is there. Then this is the acetaldehyde. Acetaldehyde, because CH3 in the place of H, CH3 is there. And CH3 came from the acetic acid. That's why name has been given, common name acetaldehyde. And IUPAC name, just like methanol, it is ethanol, because 2 carbon is there. Ethane, E and the end E was removed and Al is added. Now third example I am telling you, CH3 whole 2, CHO, CH3 whole 2, CHO. Just like 3 carbon, propane is there, but here methyl group is attached. Then you know that from the aldehyde, nearest from the aldehyde group numbering will start, carbon number. Then here CH3 whole 2, CHO. Then what will be the common name? Then because it is a branch, methyl group is attached. One methyl group has a branch. Then it will be iso, because total carbon is 4, including CHO. Total carbon is 4. Okay, that's why it will be called isobutyr, butyr, butyr aldehyde, isobutyr aldehyde. In the end, iso, because it is a branch, butyr, butyr, or butyr also you can tell, isobutyr aldehyde. This is the common name, isobutyr aldehyde. And IUPAC name, because carbon number 2 methyl group is attached at carbon number 2. That's why it will be called 2-methyl propanol. Okay. Aldehyde here you have to, for aldehyde you are counting Al, that's why it became 2-methyl propanol. Now next example is cyclohexane. With cyclohexane group, one CHO group is there, and after leaving one carbon, next carbon CH3 is attached. Means two group is attached. CHO means aldehyde is attached, and that meta position CH3 is attached. Means ortho no group is there, and at meta CH3 is attached. Then I told you how will you numbering here, alpha, beta, gamma. Then if CHO you consider as the carbon to which CHO is attached, that is alpha carbon. Next to that means ortho position, that will called beta, and next to ortho means meta position, that will be called gamma. Okay. Then now this at gamma position methyl group is there, and both group are attached with cyclohexane. Hence name will be gamma methyl. You know that alphabetically naming is done. Gamma methyl cyclohexane. Gamma methyl cyclohexane. This is the common name. IUPAC name, that is 3-methyl. You have to count from CHO. 1, 2, 3. The carbon to which CHO is attached, from that carbon you have to count the 1, 2, 3. Third carbon methyl group is there. Then 3-methyl cyclohexane carb aldehyde, because from the ring CHO group is attached. Then for that carb aldehyde is used. Already I have discussed. Hence 3-methyl cyclohexane. 3-methyl cyclohexane carb aldehyde. This is the IUPAC name. Now next example I am telling you, CH3 CHOCH3 CHO. Okay. CH3 CH, from that OCH3 is attached. OCH3 is attached, methoxy, and after that CHO is also attached. Means from that OCH3 is attached, methoxy, and aldehyde group is also attached. Then what will be common name? Then here you understand total 3 carbon is this OCH3, that is the methoxy group, it is attached, but main is the propane. Main is propane aldehyde actually, but here at alpha position methoxy group is attached. Means the carbon to which CHO is attached, that is the alpha position. Then alpha position OCH3 is attached, means methoxy is attached. Then its name will be, common name is alpha methoxy propane aldehyde. Here E you have removed and aldehyde is attached. Okay, alpha methoxy propane aldehyde. Okay, and because the total, if you will OCH3 you will consider as a group, then total 3 carbon is there. Then this will be alpha methoxy propane propion aldehyde. Okay, propion, not propane, alpha methoxy propion aldehyde, PION, propion aldehyde. What will be the IUPAC name? Then 2-methoxy propanol, 2-methoxy propanol. E you have removed, Al you have added, 2-methoxy propanol, but common name was alpha methoxy propion aldehyde. Now next example I am telling you, that is the CH3 CH2 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 CHO. Very simple. Means 1 2 3 4 carbon is attached, and in the end CHO is attached, means including CHO carbon 5. Then it is a state change, simple. CH3 CH2 CH2 CH2, 3 CH2, and in the beginning CH3 is attached and the end CHO is attached, then it is aldehyde, is 100% sure. Then here common name is Valer, VALER, Valer aldehyde, Valer aldehyde. And what is the IUPAC name? Then it is very easy. Total including CHO carbon, total is 5. Hence it will be pentanol, pentane. E you remove and add Al, pentanol. Now this always you remember, if with 4 carbon CHO is attached, with 4 carbon state change CHO is attached, then its common name is Valer aldehyde, VALER, Valer aldehyde. Now next compound I am telling you, CH2 double bond CH, and then CHO is attached, means alkene you consider, alkene double bond, CH2 double bond CH2, but from the 1 carbon H is removed and CHO is attached. Then this is actually common name is acrolein, and what is the IUPAC name? Then because total carbon is 3 including CHO carbon, then it will be prop 2 in Al, prop 2, because that carbon number 2 double bond is there. Then prop 2 in means double bond, in means double bond. Then prop 2 in Al, Al, prop 2 in Al. Okay, question is asked. This question has been asked. मैंने बात discussed that just leaving first 2, that is the easy, other are asked in examination. Then acrolein I told you, yes, that ethylene, not ethylene, ethylene, in that CH2, in that CHO was attached, then CH2 double bond was there, 1 H removed, CH2 joined, CHO joined, with ethylene CHO has joined. When H has gone, CHO has come. Then its common name is acrolein, IUPAC name is prop 2 in Al, in means double bond. Now next example I am telling you, with benzene ring, 2 aldehyde group is attached, CHO. Okay, continuously in benzene ring 2 CHO is attached. continuously. Then means one carbon CHO, the next carbon again CHO continuously. Then that is actually common name is phthalaldehyde, PH aldehyde, PH. Then PH is silent. Okay, PH aldehyde means phthalaldehyde. Okay, phthalaldehyde, phthalic acid, na? Phthalic, that phthalaldehyde. pH is silent. And this IUPAC name of phthalaldehyde. Then phthalaldehyde you can tell, phthaldehyde. Then what is its IUPAC name? Then benzene, carbon number 1 and 2 continuously CHO is attached. Then benzene 1-2 dicarbaldehyde, carb. Whenever it is attached to the cyclo group, aldehyde is attached to the cyclo group, use the word carbaldehyde. Very, very important. Question is asked. Then its name will be, IUPAC name will be benzene 1-2 dicarbaldehyde. Now come to the next again with benzene ring, one aldehyde is attached, and at para position Br is attached, bromine is attached. Alpha position CHO and para position Br is attached. Then what will be common name? Then meta-bromo-benzaldehyde, benz. Okay, benzaldehyde, and continuously you can tell meta-bromo-benzaldehyde, but it is a benz and then aldehyde you have to add, benzaldehyde, meta-bromo-benzaldehyde. And what will be its IUPAC name? Then IUPAC name will be 3-bromo-benzaldehyde, 3-bromo-benzaldehyde. Okay, in the place of M, meta, you are writing 3, because that is a carbon number 3 from aldehyde. Okay, hence all things are same. In the place of meta, you are writing 3. Then 3-bromo-benzaldehyde. Now I will discuss some examples of ketone. Okay, ketone. Then CH3, CO, CH3, CH2 means now this group will be there, ketonic group will be there, that is the must. In ketone, CO group will be there. And here you want to know, you should also keep in mind that COO group is also called ozone. These things, oxone, OXONE, oxone group. Okay, ketonic group is also known as oxone, OXONE, oxone. Then now here CH3, CO, actually acetone, you know, acetone, you first write acetone structure, CH3, CO, CH3. But now from this CH3, suppose H is not there, it is replaced by ethyl group. H gone, I need its place, and at its place ethyl group is attached. Then now one side methyl group and other side you can tell propyl group is attached. Okay, CO group is in middle, CO. Ketonic group in the middle, one side methyl, other side propyl. Then what will be the common name? that is the methyl N-propyl ketone. Always follow abbreviation alphabetical. Then methyl N-propyl ketone. And what will be the IUPAC name? Then IUPAC name here in total carbon including CO carbon. CO carbon total is 5. Total is 5. Then obviously it will be pentane. Pentane. But what will be this nomenclature? IUPAC. Then E you have to remove pentane, AN, and in that pentane 2 one, ONE, one. One means short form of ketone. Oxone is also there. Sometimes you have to use the word oxone. Okay, particularly carboxylic acid, when you will use oxalate that time. Okay, oxone is also used. But here pentane, PENTAN, 2, pentane 2, one, 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 pentane 2, one. Now next is CH3 whole 2, CH3 whole 2, CH. After that CO is there, and then again same things are repeated. CH3 whole 2, then CH3 whole 2 is repeated, means both sides CO is in the middle, left side CH3 whole 2 CH, and right side also CH3 whole 2 CH, means CH is attached with CO. CH is attached with CO. Okay. Then now what will be the name, popular name, commonly name? Then because it is a repetition of CH3 whole 2. Then 3 carbons are there, CH3 whole 2 CH. Then it is because it is total is 3 carbon, but at one it is in a branch. CH3 whole 2 is there, means one is in the form of branch. Then that's why it is called isopropyl. Isopropyl, because one this CH is attached to the CO. It is a propyl group actually, isopropyl group. It is a CH3 whole 2 is isopropyl group, remember it. Then 2 isopropyl group is attached with CO, left side and right side. Then its name will be di-isopropyl ketone. Di-isopropyl ketone. You have to do practice, okay, in speaking also, writing also. Then easily you can write di-isopropyl ketone. But what will be this IUPAC name? Then easily you can write IUPAC name. 2, 4, carbon number 2 and carbon number 4, because total 4 carbons are there, and in that carbon number 2 and carbon number 4 methyl group is attached, correct? Then CO is in the middle. Then here carbon number 2 and carbon number 4 methyl group is attached. That's why you can tell 2,4 dimethyl pentane 3 one, because at carbon number 3 O group is CO, that is at carbon number 3. The C double bond O, that is at carbon number 3. Then including this carbon, total 5 is there. Then 2,4 dimethyl pentane 3 one, ONE. Now next example I am telling you, that cyclohexane is there. In that CO group is attached. One is oxygen double bond is there. From the benzene, from the cyclohexane ring, one carbon is attached with one oxygen having double bond, means ketone. It is forming ketone. Benzene cyclohexane ring, one carbon have double bond with O, means making it ketone. Okay, and next to this carbon CH3 is attached. Next to this carbon CH3 is attached, means CO, C belonging to the ring. C belong to the ring. In that oxygen is attached. And next to this carbon methyl group is attached. Then what will be the common name? Alpha, because with this group, CO group, with respect to that, actually both are respect to each other, but in respect of, you can tell methyl you consider as a alpha position. Alpha position. Okay, methyl is at alpha position. Then alpha methyl, very easy name. Alpha methyl cyclohexanone. Cyclohexanone. Okay, alpha methyl with respect to carbon CO, that is next is the alpha position. In that methyl group is attached. Okay, then finally actually it is a ketone, that is sure, because CO is there. Then next to this group methyl group is there. Then its common name is alpha methyl cyclohexane. Hexane is there, but here you will tell hexanone. Hexane you are not telling, hexa you are telling. Alpha methyl cyclohexanone. Okay, you are not telling hexane, hexanone. What is its IUPAC name? Then in the place of alpha, now you can tell 2, carbon number 2. CO, that is the first carbon, next is methyl group. Hence you can tell 2-methyl cyclohexanone. Cyclo, here hexa you can't tell, same way you can tell 2-methyl cyclohexanone, same name. Only in the place of alpha you are telling 2-methyl cyclohexanone. And one more I want to tell you, that you should remember question is asked. Actually in all examination simple thing they will not ask. Any difficulty is there, that question you think that question will be asked. And now what I am discussing, that question has been asked in many examinations. That is in easy way, how will you understand? I am telling you. Actually in this compound, suppose it is this alkene double bond is there. Propene is there, actually propene is there. CH3 whole 2, CH3 whole 2, C double bond CH, and from that COCH3 is attached. From this carbon and the end COCH3 is attached. Okay, propylene you consider, then CH3 whole 2 C. Okay, one CH3 is at the, just like at a branch. Okay, then CH3 whole 2 C double bond CH. Only from this C, COCH3 is attached. Then CO means ketone. Okay, that means here group is only ketone, only one group ketone, but this double bond is there, that you have to understand. when ketone group is there and En is also there, double bond is also there. Okay, then it is called mesityl oxide. Mesityl oxide, MESITYL. Mesityl oxide, you remember, means here total carbon is 5. Total carbon is 5. Okay, CH3 whole 2, then that is 2 carbon, it is attached with C, 3 carbon, after that double bond CH, that is the 4th carbon. Okay, if you will, this methyl group which is branch, that you don't count because already methyl you are writing in the beginning. Then if you will not count that methyl, then it will be 5. Then CH3 whole 2C, then one CH3 don't count because already you are writing, you will write methyl group. Then CH3, one CH3 only count, 1 carbon, it is attached with C, 2nd carbon, double bond, again CH, 3 carbon, again CO, 4th carbon, and in the end again CH3 is attached. Okay, CO, CH3 in the end, total 5. Then now IUPAC name will be 4-methyl pent. 4-methyl pent. Then at carbon number 3, double bond is there. At carbon number 3, double bond is there. Means from the CO ketonic group is there, from that side you count. Then 1st, 2nd, 3rd carbon double bond is there. That's why it will be, and 4th carbon methyl group is there. Then it will be 4-methyl pent, 3 in, 2 on. Always you write the dash. Correct? To differentiate, gap should be there. Whenever writing, suppose you are writing 3 in, then before 3, after 3, dash you write every time. Even for this on ketone also 2 you are writing, any digit you are writing, then left, right, both sides dash you write. Okay. Then now IUPAC name of this compound means mesityl oxide is 4-methyl pent, 3 in, En 2 on. Okay. Then this I have discussed, can say examples of compounds, their common name and IUPAC name. You need more practice. Whenever you see any question, just nomenclature, if compound is there, then now actually you should do more and more practice. Group wise you do what in actually general way we have discussed in the beginning, nomenclature in general way. Now chapter wise also we are telling, compound wise also, hence it will be easy. Okay, it is just like calling any person with name. Okay, now I am going to discuss a structure of a carbonyl group. Already you know simple things you know, but I will tell little more. The carbonyl carbon atom is sp2 hybridized. This is the new things. Okay, CO, see double bond O, wherever double bond is there, then that carbon is sp2. Always you remember. If triple bond is there, carbon triple bond in there, it will be sp. And where single bond is there, then that will be sp3. Correct? Every carbon have 4 valency. Then sp3 means total 4 is coming, including s plus 3p, p3, total 4. It means sp3 hybridization. If you can say double bond is there, then that will be sp2 because 2 valency single valence is only 2. sp2 means here total is 3. Total is 3. Okay. Then if it is you can say carbon-carbon triple bond, then only one valency is remaining. That's why it is called sp, because S and P is taking part. In first case sp3 1s3p taken part in hybridization. In case of sp2 1s2p has taken part. Third one has not taken part in hybridization. Correct? And in sp 1s 1p has taken part. Other 2p has not taken part in hybridization. Okay, that will remain as it is, and that actually unhybridized p orbital will take part in making a pi bond. If 2 carbons are there, 1 each, then that will make 1 pi bond. Okay, if 2 are there, both carbon 2 unhybridized carbon for 2 unhybridized p orbital of 2 carbon, they will make 2 pi bond. Okay, already I have discussed. Then here in CO I am talking about ketone. The carbonyl carbon atom is sp2 hybridized and forms a 3 sigma bond. Okay, here it will form, because sp2 is there, then total 3 valency is there, 1s2p 3 valency. Then this forms 3 sigma bond. One will be double bond, you know. Okay, sp2 hybridized and forms 3 sigma bonds. Then the fourth valence electron of carbon remains in its p orbital and forms a pi bond with oxygen by overlap with p orbital of an oxygen. In addition, the oxygen atom also has 2 non-bonding electron pairs. You know that oxygen has two lone pair, actually non-bonding you can tell, it will not take part in bond formation. Lone pair of electron you can tell, 2 lone pair of electron, that is called non-bonding electron pairs, because these 2 pair will not take part in bond formation. Then thus the carbonyl carbon and the 3 atoms, carbonyl carbon and the 3 atoms attached to it lie in the same plane. This is important. The carbonyl carbon and the 3 atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. Means here you can understand, just like a paper page, that is one plane, above the paper, below the paper. Okay, then that way you can understand the carbonyl carbon and the 3 atoms attached to it lie in the same plane, just like a sheet of paper, and the pi electrons cloud, actually electron cloud, you know, that is a electron cloud. Here this pi electron, because that will make pi bond, that's why electron involved in making the pi bond. That electron I am telling you here, the pi electron cloud of above and below this plane. Okay, this carbonyl carbon and 3 atoms attached to it lie in the same plane, and the pi electron cloud is above and below this plane. The bond angle are approximately 120 degree as expected of a trigonal coplanar structure. Trigonal, because only three bonds are there. That is in they are lying only on the plane, same plane. Then 120, 120, total 360. Okay. Then this I have told about the, you can say, carbonyl group, little more. The carbon oxygen double bond. Now come to this. The carbon oxygen double bond, 3 bond I told you. Then 1 bond C and O, sigma bond. Other you know that left and right it can make, means 2 come 2, it can attach 2 more carbon. Then total 3 sigma bond. But now in oxygen, with oxygen 2 bond is there. Then 1 bond, other bond is, second bond is pi bond. The carbon oxygen double bond is polarized due to higher electronegativity of the carbon oxygen double bond is polarized due to higher electronegativity of oxygen relative to carbon. Hence the carbonyl carbon is an electrophilic, and that carbonyl, you can tell the carbonyl carbon is an electrophilic, means Lewis acid, and carbonyl oxygen a nucleophilic center or Lewis base. This is important point. The carbon oxygen double bond is polarized. Why? Due to higher electronegativity of oxygen relative to carbon. Hence the carbonyl carbon is an electrophilic means Lewis acid, and carbonyl oxygen is nucleophilic, means Lewis base or nucleophilic center also, you can tell. Nucleophilic means negative, and electrophilic means positive. E positive, Nu negative, you are knowing. Okay. Carbonyl compounds have substantial dipole moment and are polar than ethers. It is more polar than ethers. Okay. CO means carbonyl compounds have more dipole moment, substantial dipole moment, and are polar than ethers. Question is asked, polar than ether. The high polarity of carbonyl group is explained on the basis of resonance involving a neutral and a polar structure. This how we will tell the high polarity of carbonyl group is explained on the basis of resonance involving a neutral and a dipolar structure. Means CO, C and O, between C and O double bond is there. Correct? That is a structure 1. Structure 2 means now double bond will break, then oxygen will take 1 electron, carbon will take oxygen will take the electron and it will become negative, and then carbon will become positive. This is the other structure. Okay, this is the other structure. Then one is neutral because no charge was there, C double bond O, no charge is there, that's why it is neutral. And other is dipolar structure, means now oxygen is negative and carbon is positive. Then this is the second structure. Okay, then now I am stopping only here. Next class I will discuss preparation of aldehyde and ketones. Thank you.